Alright, so this is on section 6.6, which is on tests for the difference between two proportions. So let's first recall some fact. So px hat, by the central limit theorem, has normal distribution where mean is px, and the variance is px times 1 minus px over nx. And the same goes for py hat. So the difference of ps hat and py hat also has the normal distribution. Remember to add the variances instead of subtracting the variances. Now let's consider the hypothesis test. So there are three types. The first one is px and py are the same, and the alternate hypothesis is the opposite. And there's the one-sided test, which are similar. So to calculate the p-value, we need the null distribution. So notice that in the null hypothesis, we're assuming px is equal to py. So we assume px is equal to py. So the first term is equal to 0. So the null distribution has the mean 0. And for the variance, we substitute px and py because we don't know their values by the same value. It's called p hat, which is defined to be x plus y over nx plus ny. This is called the pooled proportion. So the new variance for the null distribution is going to be p hat times y minus p hat times 1 over nx plus 1 over ny. So this is the null distribution we're going to use to solve for p-values. Alright, so let's do an example. So let's have experiment X and experiment Y. So we have two different experiments. The experiment X is run 1,000 times. And then we had 530 successes. Experiment Y was run 2,000 times. And 1,000 of them are successes. Okay, so notice that this is nx, this is x, this is ny, this is y. So our px hat is equal to 530 over 1,000, which is 0.53, 0.53. And py hat is 1,000 divided by 2,000, which is 0.5. And the pooled proportion, which we'll need for the null distribution, is p hat equals to 530 plus 1,000 over 1,000 plus 2,000. This is 1,530 over 3,000, which is 0.51. So based on the sample, it looks like experiment X has higher success rate. So that's gonna be our H1. So H1 says that the X has higher success rate than Y, and H0 says the opposite. So the null distribution is the normal distribution with mean 0 and the variance being p hat times minus p hat times 1 over nx plus 1 over ny. And we have all these values, so we can just plug into the calculator. This tells us that the standard deviation is 0.01936. So let's draw the null distribution. So the mean is 0. And according to this, px hat minus py hat is equal to 0.03. So it's about here, 0.03 is our sample value. So to calculate the p-value, which is the area of this tail, we first have to calculate the z-score of this number. So z is equal to 0.03 minus 0 over 0.01936. This is equal to 1.55. And look at the z-table. We get the p-value is equal to the area of this tail, which is equal to 0.0606. So because the p-value is not less than 0.05, we cannot conclude that experiment X has higher success rate than experiment Y. Okay, all right, so that's it for section 6.6.